See this question. Prove that they have given this, and now we are supposed to show that the determinant, the value of this determinant is this one. So shortcut is, if you directly want to do it, as I said, substitute for a, b, c some numerical values like a equal to 1, b equal to 2, c equal to 3, whatever values you can choose, and then try to eliminate the options. If you see that for more than one option you are going to get same answer, then change the values and again do it. That will be faster. But anyway, let's see the procedure here. Okay, the procedure is like this, the actual proof is like this. Now if you observe it, I have taken this entire determinant and then I have multiplied this first column with a. That is why I am getting everywhere multiplied with a. And since I have multiplied the entire column with a, to balance it out, I divided with a, right? And again I multiplied this entire column with b, and since I multiplied the entire column with b, to balance it out, I divided with b, and again multiply this with c and divide with c. That is why I got 1 by abc, right? And next, from every row I pulled out a as common, right? So if every row, if I pull out a as common, I am going to get this. Since I divided this entire row with a, I have to multiply it with a to balance it. That is why I am multiplying it with a here to balance it. And again I did the same here. The entire row I am going to divide it with b. So I divided with b and then I multiplied with b to balance it out. Same thing here. Divide with c and then multiply with c. So I got abc divided by abc, right? So why did I do these two transformations is to get something, the determinant like this, so that now if you observe it, if I add all the columns, or if I add the entire row, sum of each row is same. If you add all these up, the sum of the entire row is going to be 1 plus a square plus b square plus c square, and this one is also 1 plus a square plus b square plus c square. Same thing here, right? Therefore what I'll do is I'll replace column 1 with the sum of all three columns. Therefore column 1 is replaced with the sum of all three columns, c1 plus c2 plus c3, right? Then when I replace it, the first column is going to have 1 plus a square plus b square plus c square in all the rows. The first elements in all the rows is going to be 1 plus a square plus b square plus c square, and so I'm going to take it out as common, right? So I took it out as common. Then this is what I got. Now if you observe it, it is very easy to make most of the elements as zeros by using the row transformations. If you observe this row, this is 1 plus b square plus c square. This is 1 plus b square plus 1 plus and c square. 1 b square c square, 1 b square plus 1 c square. Now if I take this R1 and if I subtract it from R2 and I replace it in place of R2, then I get some of the terms as zeros, because if I take this one and subtract it from here, I get 0 here and then 1 here and then 0, and if I do the same here, I get 0 here, 0 here and then 1. So after these two transformations, what are they? R2 is replaced with R2 minus R1 and R3 is replaced with R3 minus R1, right? If I do that, I am going to get this one, right? Therefore this is it. So this is upper triangular matrix. If you observe it, it is upper triangular matrix. The reason is all the elements below the diagonal are 0, and in upper triangular matrix or lower triangular matrix or diagonal matrix, I told you that the value of the determinant is always equal to the product of the principal diagonal elements, and here the principal diagonal elements are 1, 1 and 1. So it is determinant is going to be 1. So this is the answer. Got it? So we have proved it. So what I suggest you is, in GATE, if you have to do this entire process, it is going to be a bit time consuming. In case if you can't find out any other method, then go with this. Learning this method is good, but then try to substitute in place of A, B, C and then get the answer. In case if they have framed the question in such a way that the substitution doesn't work, then maybe this method will come to the rescue. Okay, fine.